Hello, can you hear me? Not yet. How's it going? Thanks for having me. I love Toronto so far. I had a great evening last night, and I'm looking forward to a couple more days of good time. So, glad to be here. Okay, I'm there. Oh. Helps if it's plugged in. So what I'm going to talk to you about today is what I call the art and science of shipping single-page applications. And you'll notice there's with Ember.js. So I'm in the process of transitioning this conversation to a little bit broader scope and including some other JavaScript application frameworks as well. So you're getting a chance to see the kind of transition state of this presentation. I've been doing it on Ember for quite some time now. So you can see represented there, back to this, but I will caveat that with the fact that I spent most of my time building single-page apps in Ember, and just recently taken on a new role where I'm now doing Angular and React applications. So you're going to get to see a mix of the different frameworks as I go along. Here's my information on how to contact me, where I tweet, where I open source code, where I blog, and a couple of books that I've had a chance to co-author in the last 3 or 4 years. So there is more than one way to skin a cat, you know, the old adage. By the way, do not Google skinning cats. I wouldn't recommend it. But you'll see there I also have some other logos added in, Meteor, Marionette. I don't know if you recognize those. What I would like to do is kind of narrow it down a little bit, because the landscape is so broad. What I've had to do in my different positions over the last couple of years is to narrow it down and to say what is really ready to be used in a real application that's production ready. And you can see there, I pulled out Meteor. I've pulled out Backbone Marionette, even though I've done that quite a bit. And I've kind of landed on Ember, Angular, and React Flux in the most recent of time. So as I go through this, I'd like for you guys to look at it in the way I do. And it's not really about a cage match between the three. It's really more about, and if you get into the details, these frameworks and the teams are starting to learn from each other and adopt each other's, the good parts of the framework. And they're starting to, as we've seen in the past and with other web frameworks, they're starting to learn from each other. So why have I divided this into the art and science? And it's because there's a lot of left-brain thinkers in the room and a lot of more right-brain thinkers. I'm trying to hit in the middle. I'm trying to show you code today. For some of you that don't write code, I might lose you a little bit, but I'll try to bring you full circle with maybe a higher level concept, and vice versa. I don't want to bore the folks in the room that write code. So trying to hit right in the middle. And when I divide the presentation up, I divide it up into the art, and these are the areas that I'll focus on when I do the art. We'll talk about design and dev hands-offs. We'll talk about what I call a client-side first architecture, and we'll talk about conventions and development ergonomics. And then when we get into the science aspect, we'll talk about these areas. And we'll go into some more kind of scientific, technical detail of these areas. So let me tell you a story, right? 2006, 2007, like most of you that were writing web applications at the time, I was doing traditional stuff. And a lot of people around me were doing traditional web applications. There was a lot of refreshes going on the page. And JavaScript was really more about sprinkling it on like on top of a cupcake into the application. But then I got a chance to build my first spa. If you don't know what a SPA is, it's a single page application. Yeah, you get it. So this is what it looked like. You know, it wasn't the most aesthetically pleasing web app that we like the ones we see today. But over time, it went through some redesigns. The framework behind it stayed the same. Essentially, this was for a company called USAA, which is an insurance, financial, investments company. And they had a lot of applications they needed to aggregate to a page in the form of widgets or modules. And this is kind of the solution that was come up with. These were widgets that could drag around, and you could reorganize them. Any of you that are USAA members and log into your My accounts, you'll still see this framework being run today. It's gone through a number of redesigns. I think this is the latest, the way it looks. But behind the scenes, it's still using my first single-page app implementation. So what did that look like? Well, it wasn't like what we see today. It was a little bit more manual and a little bit more naive, right, because of the times. But basically, every time a particular action would take place within the UI, we would go and notify the server, and the server would respond with what we call a JSON markup language, which I'll go into more detail later. But the JSON markup language mixed the layout and the data together, and it repainted the DOM every time something occurred that the server needed to know about. It sent back basically the whole DOM tree with embedded data. So you'll see as we move on, that was kind of naive. But it was an early single-page app. And this was me at the time. Those are kind of the Java developers in the background, and I was feeling like I was leading a bunch of people in a direction, and I felt like an imposter. I felt like, is this really going to work? I was putting all this into JavaScript, and ultimately, it's been nice to see that the idea was right, the implementation was naive, but over time, I've gotten a chance, primarily through the company I worked with before I came to my latest gig, Frog Design. I was able to work with all of these different frameworks and get a good feel for how they all work, how they're all similar, and it really validated my early commitment to JavaScript that it was going to be the future of web application development. So come 2012 to 2014, I was a lead engineer at Frog Design, and I came to a client that S&P Capital IQ, and they had this use case that was very familiar to me, except it was more evolved. And I wanted to evolve my technical implementation as well. So I started getting into Ember. It was a choice between Angular and Ember at the time, and I felt like Ember would accommodate our needs. And this was, if you remember the last slide I showed you that had this kind of conceptual diagram, all of the JavaScript, all of the application logic started getting moved to the client, and we were doing everything from routing to data to all of the MVC aspects of application development all on the client side. Now, if you remember back to the other, this is a very similar, you'll see that the S&P Capital IQ problem was a very similar problem to the USAA one, in that I needed to be able to create new tabs, and I needed to be able to add widgets. It just was done in a slightly different way. They had what was called a card pipeline, and we needed to be able to add applications into the pipeline. And you can see there was this HTML5 canvas view. It was actually a lot more complicated, but overall, it was a very similar challenge. Here, this was where you could swipe through the applications just like you could in the USAA implementation, choose a widget, add it into the page. So there's the USAA version, there's a tab, there's an edit. When you click that edit, you could alter the page, or you could click the add widgets over here and you could add widgets. The S&P Capital IQ design asked that we be able to minimize these. That was something that was new, minimizing down into the footer. But this was an HTML5 canvas that went on behind the scenes where collaboration could take place between the different users that were logged in the system. There was a whole real-time element to it, so it was more complicated. But underneath, I was using my lessons learned from this particular application to do the sub or the embedded applications part of it. So right there, you'll see that was actually an iframe in USAA wrapped into this little widget. And in some cases, we had to use iframes in the S&P Capital IQ implementation as well, because which are reasons I'll get into later, but some of these applications were so complex that they needed to be wrapped, and they needed to be done by a separate team who was not necessarily ever going to learn Ember. So we were still utilizing some of the techniques that we did in the old implementation. So let's get into, now that you know the story, let's get into these areas, and let's talk about how I've evolved things over time to get a more efficient, a better end product when we're done. So one of the things back in the day was always segregated design teams who handed off Photoshop comps, and they would throw them over the fence, and then they'd say, okay, go for it. That obviously, doesn't work very well, and it's something that that we try to solve for. We also hire nowadays, or in most of the roles I've been in, or both the roles I've been in the last couple of years, I try to hire for hybrid skill sets. I try to hire front-end engineers that have design sensibilities, so that they can understand the design challenge, and they can appreciate it, and they can respect the design challenge. And it becomes, this is, left and right brain thinking together, and it's hard to find these folks, but they're ultra important. We also design with code, which, because there's a decoupled front end, we don't have to have a server. We just can run a local web server, serve it up, and we can actually build out a large part of the application, style it, make it look nice, take care of a lot of the interactions, all in code that is not going to get thrown away. And I'll talk about more about that later too. But tooling and workflow is another aspect. I primarily use Chrome DevTools, do a lot of going into the DevTools, changing code, talking to a designer, saying, hey, look, do you like the way this looks? Add some padding, change the color. Do that in real time in Chrome DevTools. So that's another key thing that we did not have a long time ago. And then I also evaluated a lot of these prototyping frameworks to the point to where I actually went and joined one of them, which is why I have Vision App kind of highlighted at the end. It was the one that I was the most impressed with, and I had an opportunity to join the team. But these are also, I think, very important. This is a look at Envision, being able to go in and create design comps, share them with your team, and then a collaboration model where you can go and annotate, and you can collaborate over in a real-time view, see other people collaborating, and then also a Photoshop and Sketch integration where you can export and you can get your comps into something that can be shared with developers. All of those things are way different than the way we did things back when I did my first single-page application. So a little bit more on client-side first architecture. The old way of thinking was more around, architect the server first, or sometimes you hear this quote, why don't we just reuse the existing services, with some minor tweaks? And that makes people feel really good to say that, and then the developers feel really bad as we move forward. So that doesn't work, right? So I like to work front to back. It's not the ideal. This is probably the hardest part of building applications in my opinion. But if you work front to back, the front end developers can define the specification. Usually you need like a full stack developer doing that. They can define the specification, they can hard code it on the front end, they can put it in mocks, and then the back end team can come along and they can actually write the real service. But it creates a workflow that doesn't put bottlenecks or blockers into the front end. And then Ember, and I'll show you Angular and I think just Angular, how you can also do this, doesn't matter. This is kind of a framework agnostic thing. But Ember has this concept of fixture adapters. You're writing your fixtures, you're coding, you're not blocked. and then you switch over to a REST adapter, and then you connect to your backend. So the way that looks is you've got this is kind of the project view. You've got all of your front-end development going on, and you've got your services going on at the same time, and all the stuff in green is getting reused. It's not getting thrown away. We used to throw away a lot of code, writing prototypes, and throw it away. Not necessary anymore. And it's largely due to these adapters, adapter concept, where I can go in, create an application adapter, call a fixture adapter. I can also scope to different parts of my application, different domains in my application. And so as I'm coding along, say the market timeline there, you can say, well, that data's not ready. So you don't have to worry about it. You can mock that out and wait for the back end. But this data up here might be ready, so you can switch over to that data, the real data for that part of the application. And you can break up your application through different adapters in different areas. Now, the way that looks in other applications, Ember makes it very nice, but there's also things like JS data, which do exactly the same thing. They have different types of the data adapters that allow you to silo data into different parts of your application. And that's what it would look like in Angular. Basically, I'm configuring a data store provider, and then I'm setting up a resource, using the run factory, and then also I'm doing a comment.find all down there. Very similar to the way it works in Ember. It's just an agnostic framework. Here's an example using Firebase. So if you wanted to use a hosted data backend, you could use something like Firebase. Same kind of concept in Ember. There are Ember custom adapters written for Firebase. Also, if you want to get to where you are actually making network calls and you want to stand up a small dummy server or an API server that is very accessible to your front-end developers, you can do something like your Ember CLI HTTP mock. You add it to your stack, or you add it into your development stack, and you've got a little express server that you can then start mocking out services and use that to define your specification. Same thing with Gulp if you're doing Angular development or React. Very similar concept. And it makes it nice to have these layers where you can communicate with your backend team without getting blocked. Conventions and developer ergonomics. So this is where Ember really shines. And anytime you see a pros and cons matrix, Ember always comes out on top when it has to do with developer ergonomics and naming conventions and things. But you have to embrace the Ember way, which has been the downside of Ember, because these things like active generation and naming conventions can become your friend, they can become your foe. They're usually your foe at the beginning, and then they become your friend. But they do prevent you from doing things like writing spaghetti or ramen code or whatever this is. And that's really the whole point, or part of the point. To enable active generation, which, let me just explain what active generation is. It's the creation of classes behind the scenes by the engine, right? So you can go in and you can set it to true so that you can go into the Ember inspector once you've installed it in your browser, and down at the bottom of your screen you can see what classes are being generated behind the scenes for you in memory. And these are classes that you don't have to create, right? So you're writing less code, the framework's writing classes for you in memory, and you can turn this on so that you can see them. As long as you know that, it doesn't become your foe anymore, it becomes your friend. Naming conventions kind of work like this. This is a very simple example. Levels controller, levels route, levels template, levels route name. It's really nice when you come into a framework to not have to think about what to name things. Especially if you're working with a lot of developers. They start naming stuff, then you start to have to refactor, and some people get really OCD and some don't, and people drive each other crazy. It's nice for the framework to take care of that. Again, the Ember inspector, you can go in and you can see exactly what things are supposed to be named. If you've named it wrong, then it's going to tell you, or you're going to be able to see, oh, well, I named it wrong, that's why it's not showing up. The other aspect to ergonomics is having something like a CLI client a command line interface like this that encompasses all of your development workflow. If you're not familiar with Ember CLI, I would recommend, if you're writing an Ember app today, use Ember CLI. It provides all these things on the left, and all these things you don't have to worry about when you're standing up a project. Now, Angular has something similar called its CDAP project template, but it's not as nice. It still leaves too much up to you to try to figure out how, okay, am I going to use gulp? Am I going to use grunt? Am I going to use, what kind of transpiler am I going to use? All of those things. And we'll get more into that a little bit later, but it's just not as complete as Ember is. And then also React Flux has it's called the React Starter Kit, which gets you started in that direction, but it's still it comes up a little short. Modules in the object model. So let's talk about JS modules. So the history, right? There was this module pattern that came out a long time ago by YUI. How many of you have written YUI JavaScript module pattern? Just going to see what my age is going to show here. So a few of you, right? So this was when we started to write modules in JavaScript. It looked like this. It allowed you to have private and public methods. It self-instantiated itself. It was nice. It wasn't perfect at all. We also had require. Around 2010, Run.js became require, and we were able to actually manage modules in our JavaScript. I wrote a lot of require apps over the years, and there was always this boilerplate you had to go through: require, config, define, require, create. Make sure that you've included this particular script in your main script, and it was really kind of still a pain, and you needed to know a lot to just get started. Things aren't any better today. It's just kind of shifted. Now there's just so many choices that the analysis has to happen up front. You have to understand what's available to you. You get into this analysis process. Should I be using TypeScript, Chasseur, Babel? What kind of format do I want my modules in? What kind of bundler do I want to use? Nice thing about Ember CLI is it takes that all away from you, and it says, we're going to give you what we feel, the community feels, is the kind of the industry standard for these things, and they're at least going to make the choice for you and shield you from having to do all of that research yourself, right? So one of the nicest things about that is that I can just name my file index there, and nowhere in my ES6 here am I declaring what the global routes name is. It's just picking it up off of the file name, and it's compiling it, it's transpiling it, and it's assigning it for me. So literally, if I use the generator to create this file, it's going to go ahead and take care of naming it for me, essentially, part of it, but keep all the globals out of my modules. Now there's something else coming along called TypeScript, which is a superset of JS, and something very cool happened recently, where TypeScript is a Microsoft tool set. Angular 2 and Angular team decided to collaborate with Microsoft, which I thought was pretty interesting. It says Friends of TypeScript Angular. So I thought that was a big move. Again, it shields us from having to, if the Angular team, the Google team was going to come up with their own version of TypeScript or something like that, or just kind of rewrite the same thing in a different way, and then you have another choice to make. It's nice to see the team starting to collaborate a little bit. There's also another way to package up your modules, and it's called UMD, which I thought was cool that the React team decided, at least for their CDN script, that they would use UMD, and it would make it, the format could be CommonJS, AMD, or it could be any of the formats that UMD supports, so that you don't have to worry about what environment you're putting the script in. I thought that was a nice move by that team as well. So let's talk a little bit about the Ember object model, go into object models a little bit. YUI2 inheritance. Basically, we started out with, this is a very manual approach to inheritance back in the day. And I always wanted a way to write my JavaScript in more of a classical type way. But when Ember came out with its object model, basically it was very straightforward in my opinion. You can extend an object, you have an init that you can run, and you've got getters and setters, right? I'm just showing the basic inheritance. You can call super within your init. Now these are all programmatic or programming paradigms that we like and understand if we've come from that background. So if you're from this background, then it's good for you. There's also computed properties, which is one of the most powerful things about Ember. Basically, it's listening for these two properties down here at the bottom. If they change, this function runs. So if my base directory in this example changes, then the image path responds and it also updates. So computed properties are a way to bubble different changes throughout your system. And you can observe. So you can observe those changes. And every class in Ember gets these, is extended from the object. So every class within the system gets all of this goodness wrapped around it. It does make the objects heavier, but you get those nice wrappers. Still, today, Angular object-oriented code still looks a little bit manual to me. It still looks a little bit more like the YUI2 example that I gave you before. We're still calling apply, we're still calling prototype, we're still doing these manual overrides of the prototype. And this is just basically because it's based on a prototypal inheritance model that you have to understand in order to program in this style. So it's a difference in styles. So runtime. Back to the original application I was showing you, my early SPA implementation. So remember that slide? I want to walk through exactly what we were doing with runtime. So basically what we were doing is on the initial load, we were sending over a file that had all of the necessary scripts and data embedded in that initial document. And you can see there, it's kind of hard to see probably a little bit, but that's essentially what I call the JSON markup language. So it was the DOM tree with data injected. And it was sent over to the render engine within the container app, so basically the JavaScript side, as a config hash there. And there was this recursive script called render object that would run through the DOM tree and it would dynamically create DOM nodes and append them to, and then it would just do one big inner HTML and append it to the page. It was a mixture of create node, which is DOM creation, and inner HTML, see down there at the bottom. And basically, it was, like I said, it was a mixture of the two. It was two different ways to create and get dynamically created DOM into the larger DOM. Once it was loaded, after that, anytime we would do any type of action, such as a drag and drop, we would tell the server through an action handler, move gadgets called, take action, handle the move gadget, create an XHR, send it to the server. Server would say, okay, yeah, you moved the gadget. Yeah, we needed to know that. But I'm going to send you back a whole new DOM tree. And as we perform any type of, let me go back one, any type of action, move gadget, add gadget, delete gadget, change page, we would run through this runtime. It was back to the server, get new DOM tree. Sorry, I'm out of sync here. Get new DOM tree, do something else like move a gadget, get new DOM tree, come back with it. So what I want to show you is how these frameworks handle that differently. So starting with the Ember Run Loop. So whenever a change occurs within an Ember app, like a model set, the model changes, the data changes. This is actually backbone here. This is to show how not to do it. Because here, render would fire twice, okay? In Ember, actions are deferred, so they're essentially queued up together. And so when you do a model set down here at the bottom, they get deferred together into a queue, but then actual render gets called, and it only happens once. So it's a much more efficient way to update the front end. And it's a way more efficient way to do that than to go all the way back to the server to ask for how do I update the front end. So the way those queues work, like in a router transition, is there's all these different queues like async, actions, router transitions, render, after render, destroy. All of those get called, all those queues get called every time that you cycle through a state change within the front end. This is just a very technical way of looking at it. For the sake of time, I'm going to skip over that right now and jump on to the way the digest cycle works, which is very similar, but it's Angular's version of it, right? So the state changes, router change, click on something, whatever. Some value changes within the local scope. Angular calls apply and enters into this digest loop. The eval sync is processed, which says, hey, go, let me know if there's any asynchronous data that I'm waiting for. And then the whole watch list is processed, which watchers are basically where the application is watching for any changes to the data model, or what's called the scope in Angular. And as the loop will continue, because the digest loop can cause further changes, right? And so it's going to continue until everything is processed, and then it's going to exit, and then the DOM is going to render. React Flux is different, but more similar to Angular and Ember than it is to my initial example where we went back to the server. And it's got a unidirectional data flow model where basically actions come in, you've got a dispatcher that's handling, receiving them, there's stores, and then there's views, right? And the architecture is different, but essentially it's very similar as well. It's all happening on the front end, and basically the key difference is this unidirectional style, right? It's not two-way bound. It's not waiting for changes to bubble up. It's just all unidirectional. So the major shift, the idea here is the major shift from the old way we were writing SPAs back in the day is that we've gotten rid of adjacent markup language is the primary thing. And we've moved towards having all this logic encapsulated on the front end, and the only time we talk to the server is just for data. One of the other key differences is the way promises came around. Sorry. And the async router is just basically a promise-based router. I should have removed that. But anyway, RSVP is the library that Ember uses for promises. And it's following the promises A+ specification. It's ES6 compliant. It provides you a lot of different convenience methods. Here is just a basic example of an RSVP promise. It looks like most other promise libraries. We'll get into some of the little bit of differences here in a second. But it's basically a way to, let me show you how we used to do it. We used to It'll make more sense once I get here. Okay. No, I'm not going backwards. Can I go forwards? Okay. So this is the way we used to do it. We would call something like a connection manager, and we would have a success and a failure object. What would happen is we would have to embed these inside each other, and we would get this kind of mess, this big messy tree of different calls, callback hell. And let me try to go back here. And now it was that, and it was a combination of continuation passing style code. So we would pass these continuations in, which were basically functions, and we would run those. This is just a simple example of us doing that. But the idea is that now with promises, we don't have to do that. In Ember, our route handlers basically have this model hook that can resolve a promise for us as well. So a model hook is basically when you change state in the application from one route to another, this hook fires. That's where you can go get your data. You can call something like Ember data, which is going to resolve a promise and make your data available to the front end, which then will update the UI. Sometimes you need to run a bunch of promises. This is a convenience method called all, where you can run a bunch of promises together and then resolve. Once those are all resolved, then do something. And the same thing with hash, which is a great way to update a UI from a number of different data sources, because then you can kind of wrap them in another object and make them sub-objects of the page, or sub-models. Now, Angular uses Q, which is a similar library, which is also ES6 compliant. It does one thing. One thing that's nice about it is it's built-in. It's a built-in service, so you can access it within your controllers. You also you have two styles that you can use, a similar style to what I just showed you, but it also preserves the old jQuery deferred style, so that any of you that like to write in that style, you can still do that. Now for React, basically it breaks it down because React is such a modular framework. You can break it down into, you can add in whatever plugin you want. So if you want to use the ES6 promise module, you can. If you want to use React Deferred, you can. But so you can use either style based upon your preference. So here's an example of React using the ES6 promise, and here's an example of React using the old or deferred promise. So HTML and JS templating is another area that has changed quite a bit since the original days. Again, I was showing you the JSIP markup language, and we were using create node. What we started to learn was we needed to generate some iframes, and we needed to do some DOM creation that was very expensive in older browsers like IE6. And so, as you can see there over in that chart, iframe is extremely expensive to DOM create. So we ended up with a mixture. We would do inner HTML for iframes. We would do DOM creation for other things like divs, simple things like that. And so we kind of managed it on our own very manually. Now something like when Ember came along and handlebars, it was primarily a string concatenation system that looked like this. It would take handlebars out of the DOM, it would compile it, and then it would output it and do an inner HTML. And it was, over time, the team started to migrate towards a different implementation, which I'm going to show you in a second. One of the things we also do a lot differently nowadays is we pre-compile our templates and we send them to the browser so they can be stored in memory. And that's something we were not doing back in the day. And handlebars basically gives you a lot of different ways to use variables, minimal logic, links and lists, and bound attributes. But essentially over time, the Ember team decided that HTMLbars was they came up with HTMLbars as the new framework, or the layer that should sit on top of handlebars. And HTMLbars is essentially using DOM creation instead of string concatenation for performance reasons. Browsers are higher performing nowadays. There's a number of different reasons. Now, another aspect that comes to mind when we talk about JS templating in HTML is that pollution is kind of bad. And we're taught from very early on to keep all of our HTML, our JavaScript, and our CSS abstracted from each other. And so when you look at Angular directives, you start to see pollution of the HTML. And that's the first impression that I got, was I want to stay away from Angular because of the pollution. Up at the top, those are just some built-in directives. And then you look at something like React as well, where basically they're starting to pollute our JavaScript with HTML, kind of the reverse. And then you get into something like MG React, which is when you're using React within Angular, and you're doing both at the same time. You're polluting your DOM and your HTML, and you're polluting your JavaScript with HTML. And basically, what I've come to is that, first of all, this was very, very unattractive to me. There are some reasons that this has become actually very convenient. And I want to show you that when I get into componentization, right? The last area that we're going to talk about. So back in the day, we were using a lot of iframes, I said, which solved some process problems. There were some process problems around, traditional web developers could then add content because it was easier. They could write an app. It could be a Java app. It could be a Ruby app. It didn't matter. And you could just call it and it would load into the system in an iframe. So it solved process problems. You could sandbox the content. There was a security element to it that was nice. You could post message back and forth, which was a little messy, but you could get data from inside your iframe out to the container. And then the other thing was that the JavaScript developers didn't have to learn the container. So whatever your crazy JavaScript you were writing in the container, it didn't matter. But then web components started to pick up steam. And when I talk about web components, I'm talking primarily about custom elements at this point in time, right? These other specs are still evolving. To me, they're not. Shadow DOM is relevant, but the others are just not as relevant yet. In my last book, I put together, sorry, I'm having trouble with this key here. I put together a couple of examples of Ember components, and one of them was a heat map that was built in V3. And basically, this is how, I broke it down into very simple. I could write a div inside of this heat map HTMLbars file, store that off into a components directory, and then the same thing, like inside of my another completely other file, I could use heat map custom element to make and then pass the data model in to make this whole component render using a third-party library. The heat map just extended the Ember component, and it was all based on what's called the did insert element, which is a hook within the view of an Ember app that allows you to embed something into this particular componentized piece of the application. And this was simple as this: did insert element called draw would draw the heat map. It's a very nice encapsulated little piece of functionality within the larger application. Angular does something very similar with custom directives. You essentially do, it's very similar. The only thing that really is different, you'll see that we're creating one called myTable. We can find the particular HTML. We can declare what the controller is. But the way you declare it, you get 4 different ways, and that's kind of nice. Now React has its own way of doing things, obviously, but the entire system is built around components. And while that seems like it solves one singular problem very nicely, it needs something like Flux, which is the architecture to provide all of the other things that are necessary to build an actual real application. It needs that to complement just the view implementation that React provides. And the nice thing about it is that there's a components database that's now being available, where you can go out and you can find these components, you can pull them in. That looks like something like this, where I can just go out, get this simple table, I can get a table here, this is different than that table, it's slightly different implementation. And finally, I can compose them together. So here's an example of how I can use a drawer component, a main view, and I'm using the main view inside of the drawer, and I can compose an application, piece it all together using these React components. So while at first I thought that the polluting of the DOM, polluting of the JavaScript, HTML inside of JavaScript, was just a complete turnoff for me because it's what I'd always been taught to abstract things. When you start to get into the details about what these different frameworks are providing and what your eventual use cases are, you can start making decisions on what's really important to you, right? So if the composability of a page, doing it quickly, using something really light and fast, unidirectional data flow, then React becomes very attractive. If you're going into an enterprise where you want to make sure that all the developers don't have to do any boilerplate up front, and they need to build out an application suite that in a dev suite that is already done for them, Ember CLI is extremely attractive. So hopefully in all these areas I was able to provide you guys with enough to start getting the wheels turning around the differences of the frameworks and provide it in the context of history and where we came from 8 to 10 years ago. Thank you.